Okay, so welcome to Solving Equations Day 2. Still on section 1.3. Today we're going to do the same steps that we did yesterday as we were solving equations. It's just today we're going to see a lot more fractions and we're going to also be introduced to decimal equations. Same process, different starting looks, but hold on to the fact that ultimately our goal is the same thing, to solve an equation so that we get our variable all by itself equaling some numerical term. Here we go. The only definition I have for you is a word that you'll hear me say quite often as we're going and dealing with the fractional terms that we see today. And that word is equivalent fractions. The word equivalent means equal. Inside you can kind of see the equi part of that. So it means equal fractions that we're looking at. Ultimately for us, what that means is we're looking to change the look of the fraction, but not its value. So if I look at specifically an example of 1/2, I could say 1/2 is 0.5, but so is 4/8. It just has a different look. And what I want you to hold on to is the reason we might make that change is because I might need a denominator of an 8 to make all my fractions go away. So by making equivalent fractions, I can get rid of my fractions in one step instead of multiplying it over and over and over again. So please just kind of hold on to that, and you'll hear that come back later on when we work with our fractional coefficient examples. So the rules and the steps that we talked about yesterday are still the same even for today. Same to everything. If you see parentheses, you distribute. If you see fractions, get rid of them. Can I combine similar terms? Again, remember on one side only that we're looking here. Box your variable terms. Move your variables together onto one side through addition or subtraction moves. Move constants together on the opposite side through addition or subtraction moves. And then once you have your variable term on one side, numerical term on the other, you divide by the coefficient attached to the x. Now I have an additional little note here that sometimes it could happen as you're doing examples with solving that when you get rid of your parentheses and you deal with your fractions and you combine similar terms, and if you go to move your variables together on onto one side, sometimes those variables all cancel out. And if your variables all cancel out, you really have two different possibilities. It means that you can't, first of all, get to one concrete number. So your solution is either all real numbers, if you get something that's true, like 3 equals 3, or it's no solution if you get something that's false, like 3 equals 5. You're going to see some of those examples in class tomorrow, and we will try to put one up in the check-in as well. All right, so here's an example or a look of what's known as a fractional coefficient. And again, just like always, we're going to start and we're going to put our line through the equal sign. But the difference is here compared today to yesterday, I have more than one fraction. And this is where the equivalent fraction is going to come into place. So what I want you to do, a quick way to do this, is to just take your two denominators and multiply those two together and say, what is that result? Well, I know 4 times 5 is 20. Now, for us, that's known as an LCD. It's the first number that both 4 and 5 go into. So you can think of it as an LCD, or you can always just multiply all your denominators together. The more fractions, though, the larger the number, so be careful of that. So what I'm going to do to find an equivalent fraction is I'm going to say if 4 times 5 is 20, notice I'm just changing the denominator, but everything else is still the same. Except for, as I change the denominator, I also have to change the numerator. In order for this 4 to become a 20, I have to multiply it by a 5. And whatever action I do to the bottom, I need to do to the top. So my equivalent fraction is 5/20. If you look at the second fraction, I needed to multiply that 5 by a 4. Whatever action you do to the bottom, you need to do to the top. So I have an equivalent fraction of 8/20. Now, as you look at that, notice that both denominators are the same. The numerators have changed, and that's fine, but everything else the x's, the 39 has remained the same. So now what we're going to do is we're going to multiply every single term by that equivalent fraction denominator of a 20. Now we do this so that as I multiply, notice that my fractions all go away at one time. So I'm left always with just my numerator and the x, and then my numerator here as well, which has an x after it. Now our values today, because we are going to be dealing with equivalent fractions and LCDs, the values are going to be a little bit larger. So you might want to have your calculator handy, but 39 times 20 is 780. So now we have no more fractions. So now we look to combine similar terms. On the left-hand side, I have 5 x's, and I'm adding to it 8 more, for a total of 13 x's. Still equal to 780, so I have variable term on one side, numerical term on the other. So I'm going to divide that coefficient away from the x, and I end up with x, and as you divide 780 by 13, you end up with 60. And there's your final answer for that fractional coefficient. So now we have 3 fractions that we're seeing, and again we're going to do the same thing. This time I want you to think LCD. And as you look at that, we're looking at a 3, we're looking at a 6, and we're looking at this 2. Always focus on the fractions first. And what we're going to say when we think LCD is it can never be the smaller values. So always pick out the larger denominator value. In this case, it's a 6. And then what you ask yourself is, can 3 be multiplied by a beautiful integer number, whole number, natural number if you will, to get to 6? And the answer is yes. And then you go to the 2 and say, can 2 be multiplied by a natural number to get to 6? And the answer is yes. So that means for us the LCD is 6. And for sure you could use that as a common denominator, which I'm going to do as I set up my next step. All of my fractions are going to change to that divide by 6. Now you for sure could go 3 times 6 times 2, it gives you 36. It's not a huge number, you can go through it that way if you want to. But I'm going to use the LCD in this particular example. So notice that the denominators are all set up by 6's, the x's were all placed where they normally were. Right now what I have to do is work on the numerators. So 3 times 2 is what gave me the 6, so I multiply that to the top as well. 6 times 1 is what gave me 6, so I multiply that to the top, and notice that that fraction didn't change. There's the x, and then the minus, and then the 2 is multiplied top and bottom by 3. So 4/6 is an equivalent fraction to 2/3. 1/2 and 3/6 are also equivalent fractions. Now that we have the same denominator, what we're going to do is multiply every single term, including that 1x that had no fraction, by 6. So the 6's will cancel out for my fractions, and I'm left with the numerator. So I have 4x's plus 5x's equals 6x's here, as we multiplied that x by the denominator term, minus our numerator value of 3. And at this point, notice I no longer have any fractions. So it kind of goes into that familiar world. Combining similar terms, I get 9x on the left-hand side. Boxing our variable terms, I see that my smaller variable term is the 6x, so I'm going to subtract it across. And I get 3x equals -3. And the last step for me is to divide over that 3, pulling the coefficient away from the x, and it leaves me with x at -1. Just be careful when you're dealing with this, whether you go LCD or whether you multiply. Just make sure that when you multiply to get rid of the fractions, if it is fractional, you're left with your numerator. If it has no fraction, you're getting multiplied by that whole piece, whether it be LCD or just whatever number you used. Our third and our example is a decimal equation. It's a different look, and all you need to know about a decimal equation is that you have decimals together. What we're going to do is treat everything the same as what we've done, and it's actually easier than fractional coefficients for us to work on. So a line through the equal sign, I'm going to do a checklist and say, do I have any parentheses? Which I do not, so I don't need to distribute. You then say, do I have any fractions? Visually you don't. Ultimately you do, because 0.6, 0.5, and 2.9 can be written in terms of a fraction. But we're going to keep it as a decimal so that visual look of a fraction's not there. I can't combine the 0.6g with the 0.5, so I can't combine similar terms. So what I'm going to do now is box this g term. And I need to move that 0.5 away from it, so because it's a positive, I'm going to subtract 0.5 away from that g term. So on the left I have 0.6g, and on the right hand side, the key thing to remember about adding and subtracting with decimals is that you line them up. Think of my last name. So when I subtract 2.9 and negative 0.5, I end up with a positive 2.4. Now that I have variable term on one side, numerical term on the other, I just divide by 0.6. So my g is all by itself, and if I take 2.4 and divide it by 0.6, I end up with a beautiful number 4. Now that's a concrete value. Sometimes when you're dividing with decimals, you'll get a decimal that's irrational, never ends, never repeats. And you might be asked to take it to the hundredths place or the tenths place. And just remember what those placeholders are. And if you are asked to specifically here estimate or approximate, we use this symbol of a little squiggly equal sign, and then you take it to whichever placeholder you have.